All right, class, let's start the 7.2c lesson. And this is on scale factor and how scale factor affects surface area and volume. Okay, so very, sounds kind of complicated right now, but I'm just going to remind us, and we're going to go over some examples about how scale factor affects the dimensions and how does that affect total area and total volume. Okay, so I'm just going to start off with an example of, let's say we have a cube that's 1, 1, 1 all around, 1, 1, 1, 1, and let's say the scale factor is 5. What would the new dimension, or what would the dimensions be for the square? Well, you could see that a scale factor of 5 significantly makes the area a lot bigger. It doesn't make the area 5 times bigger, right? The area of this original used to be 1. 1 times 1 was 1. But now this area is 25. Why? Think about it. Why did the area get 25 times larger than the first original area? Right? It has everything to do with the dimensions, class. So let's go over this paragraph. What do you think will happen to the volume when you enlarge a common object by a given scale factor? What do you think will happen to the surface area? Write your hypothesis below. So if I multiply each dimension, keyword is each dimension, by a scale factor, then I think the surface area will obviously be affected. But not only will it be affected, the surface area will increase or decrease, right? It doesn't always have to increase, by the scale factor squared. The area is not going to change just by the scale factor, because we know that area, class, is two-dimensional. So if you multiply each dimension by the scale factor, the area is affected by not just the scale factor. The area will be affected by the scale factor times the scale factor. And in this case, in my example, in the first example, 5 times 5 is 25. That's exactly why this area is 25 times larger than this one. Area is two-dimensional. The volume, though, how many dimensions does volume have, class? Right? The scale factor will increase or decrease the volume by the scale factor cubed. Not just squared this time. It's cubed. Because it all depends on the total number of dimensions. So since volume has 3 dimensions, each dimension is affected by the scale factor, and it starts to get bigger and bigger and bigger. All 3 dimensions get affected, and that means the scale factor times the scale factor times the scale factor will be the overall change in the volume. Okay, this is a very key concept, and I'm going to go ahead and provide another example. So I always like starting with the most simplest basic amount, the number 1, 1, and 1. Okay, think of this as like a very small cube. Now, let's say, class, that the scale factor was 3. So if the scale factor was 3, it would make all 3 of these dimensions multiply by 3, right? The scale factor affects all the dimensions. Now, a couple things. let's first talk about the surface area of this cube. The surface area of this cube is actually 6 because there are 6 faces and each face is worth a value of 1. So it's just 6. The volume of this cube is really just 1 times 1 times 1, which is 1. Okay, not too exciting right now. But if I use a scale factor of 3, class, so we have 6 and we have 1, right? If I use a scale factor of 3, it'll look like this. Now, a common misconception, class, is some people will say, "Oh, Mr. Quote, is the scale factor is the original image 3 times bigger?" Well, I mean, it's not 3. The dimensions are 3 times bigger, right? It's a 3 by 3 by 3. But you'll see that the surface area is actually 6 times 9, which is because there are 6 faces of 3 times 3, and that's 54. And that's actually 9 times bigger, right? But the volume is the key here, because now the volume of this cube is not just 3 times bigger than this volume. The volume of this cube is not just 9 times bigger than this volume, because that means the volume would be 9. The volume of this cube is 3 times 3 times 3, which is 27 cubic units. It's 27 times bigger. And that's not a coincidence, because that's exactly 3 times 3 times 3. Okay, so you know that the scale factor affects surface area by whatever the scale factor is squared, and the scale factor affects volume by whatever the scale factor is cubed. Okay, so let's go ahead and practice some problems. Okay, so let's go all the way to activity 2, and let's see what it says. For each of the following problems, find the necessary measurements to answer all the questions. A cube with side lengths of 8 centimeters, a cube, is enlarged, so its side lengths are now 24. Okay, so let's draw this. Now, it's not going to be drawn to scale. I just kind of did an example just like this, so this might be review again. But it's an 8 by 8 by 8 cube. And now its lengths are, I'm going to make this bigger, but it's not really drawn to scale, so, but it's going to look something like this. Now it's 24 and 24 and 24. So you know that the scale factor was what, class? We know that the scale factor was 3, because 24 divided by 8 is equal to 3. Now, what scale factor will the surface area increase by? Well, let's test this, right? What was the original surface area? The original surface area was finding the area of one face, which is 8 times 8, and then multiplying it by 6. Again, why 6? Why do we keep multiplying by the number 6? Well, it's because it's the amount of faces the cube has. So this is 384, and we don't know the units. Oh, it's centimeters squared. Okay. Now, let's go ahead and do the same with this. All right, this is going to be a lot bigger. It's 24 times 24 times 6. Again, the 6 is because there are 6 faces. 24 times 24 times 6 is 3,456 centimeters squared. Now, how many times bigger is 3,456 comparatively to 384? Boom, it's 9. That should not be a surprise, class. 3,486, which is the new surface area, divided by the old surface area, is going to equal 9. Right? And then we could also do new volume divided by old volume. Well, the new volume is 24 cubed. Old volume is, and you are actually can realize that this is 27 times larger. Right? All I'm doing is I'm calculating the new volume with the new dimensions, 24 times 24 times 24, and you get a huge number. And I actually don't even need the number because this ratio is 3, that ratio is 3, and this ratio is 3. And really, you know that the volume is affected by the scale factor, by whatever the scale factor is 3 times. That's why we call it cubed. Okay, this is kind of like an abstract concept, but I hope this example made sense for you. Okay, now if it didn't make sense, you might want to review it. Notice how all I'm doing is I'm finding the surface area of a cube. All I'm doing is I'm finding the surface area of the new cube and dividing it by the old cube. And I'm calculating how many times bigger is the new divided by the old. We said earlier in this lesson that the new surface area is going to make the old surface area. It depends on what the scale factor is, and in this case, since the scale factor is 3, this is 3 squared and this is 3 cubed. Okay, it's not a coincidence, class. This is 3 squared and this is 3 cubed, and has everything to do with the amount of dimensions. Okay, please review this and let me know if you have any questions.